Welcome to this pre-calc discussion of a little explanation about asymptotes on exponential functions and log functions. What you can see on this graph is this blue function is the graph of, well, that's kind of purplish, but the blue function is y equals 10 to the x. And the key points on 10 to the x, this is an exponential function. If I look at 10 to the negative 1, so when x is negative 1, y equals 1/10. When x equals 0, y equals 1, because it'll be 10 to the 0 power is 1. And when x equals 1, y will equal 10, because 10 to the first power, so 10 there, is 10. So you can see that here. Here's the point 0, 1. You can't see the point 1, 10 because it's way up here on the graph, but you can see the point negative 1 is a real small number. If this is 1, this is 0.2, 0.4, 0.6, 0.8. So that's at 0.1. So you get these 3 points. Well, when you look at the graph in red here, in brown, it's actually brown. I'll do it in red pen. What I've graphed here is y equals the base 10, log base 10 of x. And when we have a base 10 log, we don't really write the 10. It's just log of x. So the other thing you saw about the exponential, by the way, which I didn't do a good job of pointing out, is you have a horizontal asymptote at y equals 0. And the domain, x is all real numbers. Any number can be put into x, but because you had 10, which is a positive number raised to a power, there is no way you can take 10 and raise it to any power and get a negative number. So y is always going to be bigger than 0. That's the range. So that's of your exponential function. Now what you have to keep in mind is that a log is the inverse of an exponential function of the same base. So this is the inverse of 10 to the x. If I do y equals log of x, common log base 10. So when we do an inverse, we switch the x's and y's. So I had, for the 3 points I had for my exponential function, I had when x equals negative 1, y equals 1/10. What I'm going to have is when x equals 1/10, y equals negative 1 for my log function. In my exponential function, when I made x 0, 10 to the 0 was 1, so I had the point 0, 1, so I'm going to have the point 1, 0. I switched the x's and y's because they're inverses of each other. And when I had x is 1 in my exponential function, I got y is 10, so I'm going to get x is 10, y is 1 as points on my log function. And you can see that here. When x is 0.1, which is right about there, y is indeed negative 1. When x is 1, y is 0. And I don't show x is 10, but if I did, it would be y is 1. So based on that, let's get to the idea of asymptotes. Y equals 0 is a horizontal asymptote of an exponential function. So you change, instead of y equals 0, you have x equals 0. And x equals 0 is a vertical line. It's this axis here. X equals 0 is a vertical asymptote. So anything that was horizontal for the original function, like this, is now vertical for the inverse function. So this is a vertical asymptote. In this vertical asymptote, you do not cross it. You never can get. So the domain of your exponential function was all real numbers. That means the range of your log function is all real numbers, like the y's. The range over here of your exponential function was y had to be greater than 0. So the domain of your inverse of that, which is a log function, is x has to be greater than 0. And that's why you have this horizontal asymptote. You are never going to get a graph of a log function over here if it's just a simple unshifted log. You cannot take the log of 0 or a negative number. I hope that helps. And take a look at this and email me